Hello, and welcome to Run Fast, Catch Performance Regressions in Python. I'm Everett Pompeii. I'm the founder and maintainer of a tool called Bencher. And today we're going to be talking about how to catch performance regressions. Now, in order to catch a performance regression, you have to first detect it. Detection is a prerequisite to prevention. So when are we able to detect performance regressions? Well, we can do that in development, or we could do that in CI or in production. And more often than not, that ends up being in production, which is unfortunate because that means it's impacting our users already. And whether or not we have an observability tool and we can see that before anyone complains, they're nonetheless probably experiencing it. So we would, as developers, want to shift left as much as we could the detection of those performance regressions. So that's what we're going to start off talking with today, is about how to detect those performance regressions using benchmarks. And but before we get into that, I'm going to kind of tell a little tale that may or may not be reflective or similar to some personal experiences, but for all intents and purposes is fictitious. So we've got an app. I've got an app, V0 of the app. It's a basic calendar API, right? And so it allows people to schedule things and create events and things like that. And so this is created in Flask, but it could very well have been in Django or in Fast API. Take your pick. So got this calendar app. It's working great. Got the V0 app, a minimal lovable product, right? And then I decide, hey, I want to add an additional feature to this, right? And so a fun notification feature. So every few days, it gives our users a fun notification, just kind of out of the blue, right? Help keep engagement. So we're calling this the Fizz feature. And so with the Fizz feature, it returns Fizz if the day is divisible by 3. Otherwise, it returns none. And it's pretty simple feature to implement. The business logic looks like this. It's the fun notification function. It just takes the modulus of 3, and if that's 0, then it returns Fizz. Otherwise, it returns none. So, that's great. Release it to the customers. They love our fun notification feature. And so, I'm super happy, and I'm like, hey, I'm gonna make this even better. And I think you guys might kind of know where this is going here, but I decide to improve the fun notification feature, right? And I add buzz. So return Fizz if the day is divisible by 3, return buzz if it's divisible by 5, or Fizz buzz if it's divisible by both. So otherwise, still the same, return none. And again, this business logic is pretty simple, right? It's just that same modulus operator, but this time we got both Fizz and buzz or Fizz buzz. So I ship that to my customers, and they also love it. And so I've got version 2 out, and things are going great, and they love it so much. I'm like, hey, you know what? I think I'm going to add something else to it. And I do my full desired implementation of the fun notification feature, right? Which I call Fizz Buzz Fibonacci. So Fizz Buzz Fibonacci, though quite a mouthful, it starts the same as the good old Fizz Buzz feature, which, the 3, the 5, or both, except if the day is divisible by 7. Then it returns the nth step of the Fibonacci sequence. Otherwise, return none. And still, that business logic looks pretty simple, I just have that extra 2 lines up top where I'm checking for the modulus 7. And then I just do the Fibonacci sequence. And I moved on with my day and shipped it out to customers, and they loved it, and things were going great until 3 weeks later, when all of a sudden production was on fire. And I was like, what's going on? What's happening? Right? I shipped a bunch of code between then and the past 3 weeks, right? And so I had to come in here and spend all day coming back to try and figure out what was going on before I figured out it was this darn Fibonacci feature that I had done 3 weeks prior. And so I started looking at this and said, I should investigate. I should investigate a little bit more. And that's what I did. Went and looked at my Fibonacci sequence function, and I had done a very naive implementation of it. And so, I think you guys are probably smarter than I am and know that I shouldn't have done this to begin with. But before we dig into all that, we're going to kind of do an aside and look at benchmarking in Python and how I could have, take this as a learning experience and go and benchmark my naive implementation as I try and find a better solution. So pytest benchmark is a very popular benchmarking suite within the Python ecosystem. There is also another one called airspeed velocity, which isn't quite as popular, but is also pretty well known. We're going to be working with pytest benchmark here because it works and integrates so well with pytest. So in order to install pytest benchmark, super easy, just a pipenv shell, and you just install pytest benchmark. So I have my naive Fibonacci implementation here in my fun notification.py. And so I'm adding a benchmark to it that basically cycles through every 7th day of the month and checks to see how long this takes to run. Now, the key parts in this and where pytest benchmark, how it works, is you're passing in this benchmark argument. And that expects to take a function here, and then it basically just times that function. So however long it takes that function to run is your benchmarking time, essentially. And so here we're going through every 7th day of the month just to kind of get a feel of like what the full scope of the time that it's going to use is. So in order to run this, you just run pytest and then your file with your functions, just like you normally do with pytest. And this is the output that I got for this naive version, right? It's pretty high. It takes over 1/10 of a second to run, which is at scale not a good thing when you have a lot of people using. When I had a lot of people using my calendar app, right? So then, if we wanted to, which is going to be important later, we can run save on our benchmark output. So this will save it to a directory, which we can add to Git, which then means that over time we can track these benchmarks, even just kind of running them locally here. And so we've got my, tested, benchmarked, naive implementation here. And so now I'm going to go and add some memoization, which, help improve the performance, hopefully, of my function. And do the exact same test. Notice the test has not changed. The benchmark has not changed, but just the Fibonacci implementation has. And so I run that again, same exact call to pytest, and I get this output, which it's like a 1/6 less to run, right? Because memoization helps memoize. So, so that is a definite huge performance improvement. Now, if we wanted to compare those, we could copy and paste or whatever, but pytest does actually give us a really nice way to compare. You can just pass the number that it kind of keeps of the previous version to kind of compare those within those saved benchmarks that we just did. So we run that and we get this output, which lets us see, our version now versus that previous naive version, right? And how drastically improved things are. Which is pretty great. So that is a great example of how to run and compare with pytest. Now, a little note on micro versus macro benchmarks, right? So far, we've been doing micro benchmarks. I think these analogously as unit tests, unit level benchmarking. And so what this does is it's really about just like a single function. Versus what are called macro benchmarks, which are much more like integration tests. They're kind of full end-to-end. So with my Flask app that I'm using for my calendar API here, here's my endpoint, right? And this is the fun notification endpoint. It gets the date time it gets the day from there, and then it calls my fun notification function, and then JSONifies things, and then sends it out. And so the thing is, like, I will be benchmarking all of that. So if there's any changes outside of my code, it's great because I also can like detect that if there's any regressions in libraries I use and things like that. But it is a bit more noisy because of that. And you're also just going to have larger values. Just a thing to know. So, but they work pretty much exactly the same way, in the same way that unit and integration tests are very similar. So back to our FizzBuzz Fibonacci feature, I have implemented my memoization, and I was very silly before, and I implemented originally very naively. So now that we have that fix in, things should be good to go, right? And so I'm able to come in, play firefighter, and put out the fire that I caused in production, which is good. Things aren't on fire anymore. But like, why do I have to play firefighter? It'd be preferable if I didn't. In the same way that it's preferable that you catch your performance regression or your feature regressions before they make it to production and impact your customers, it would be great to be able to catch your performance regressions before they make it to production and impact your customers. And so you could have observability tools and they could help, but still that is too late, right? Like, you're still impacting your customers and users. And so was I in my calendar app here. So production is just too late to catch things. And then development is local only. So you've got those save tests and things like that, but it's very set to like only the one environment that it's running in. And it makes it very hard to like share that across a code base with multiple users in a development team. And so it's great for local benchmark comparison, both in pytest and airspeed velocity, but it is local only, really. And then in CI, continuous benchmarking is the thing that we're going to talk about next, which is what allows you to detect and prevent these performance regressions in CI. We are going to talk about Bencher, but I will note that airspeed velocity is also has some kind of rudimentary, basic continuous benchmarking functionality, which if you're kind of looking for a simpler tool to use, that might be worth checking out. But Bencher definitely has much more features and is much more robust in this category. So we can go forward taking a look at Bencher. So what if we had continuous benchmarking? What if I had continuous benchmarking when I was doing my calendar API, right? So rule number one, let's go time travel back, but yeah, don't set it to 2020. And so this is Bencher. It's the GitHub repo of the open source tool. And so as we time travel back here with my calendar app, and I'm at that first version with the Fizz feature, right? What would this have looked like? So I would have gone ahead and written a benchmark at that point in time, as opposed to kind of, trying to do that proactively, I think is the best way to put that. And so it's a very similar sort of test function as what we wrote before, but it goes over every single day of the month, right? And tests to see how our function performs for our business logic. And so it records that. And then in order to run that in CI, we would need to download the Bencher CLI and install it. It's just a simple Debian package and super quick and easy. And then we'd run that as part of our CI process. And here we're keeping with the pytest example, the pytest benchmark example, and we are going to output our results to a JSON file, and then Bencher, the CLI, will read that in and take that information and store our results. So that's great. We've got our version 1 instrumented. So then as we move on to version 2, we don't really have to do anything. It just picks it up and runs it in CI, and we don't have to manually test anything locally or do any work. It's just automatically picking up and doing the work for us. So that's great, and things just seem to be going well. So then as we move on to version 3, right, with that naive Fibonacci implementation there, we'll get an alert. which is great because things are running incredibly slow compared to what they used to. But how does this happen? Let's kind of take a look at that. As you track your benchmarks with Bencher, you kind of have that first version, right? And then second version, you add a little bit more functionality. And that third version is when you get a huge performance spike, right? And so that is what triggers the alert. And so don't worry, we're not getting too much in the statistics here, but this is just a probability distribution, average kind of distribution of what you'd expect. Even if you reran the results multiple times, there'd be some variation, right? And so with that first test is be right there in the middle. And then as you run kind of your second version of the code, right, those are going to be clustered. The averages of those two is going to be very close together. But that third Fibonacci, right, is going to be all the way out in the extreme. And you set a threshold in Bencher, and if anything's outside of that threshold, which more than likely that Fibonacci sequence, naive implementation would have been, then that is what triggers the alert. So that helps you catch performance regressions in CI. Instead of you manually having to do it yourself, you're able to have CI do it for you and rely on that to catch it. So we looked at and talked about trying to catch things, retroactively in production and all of the work that takes, putting out the fires and things like that. It's just simply too late. We took a look and learned how to run benchmarks locally, which is with the very useful tools that the Python ecosystem offers, pytest benchmark, and there's also airspeed velocity. And then we took a look at using continuous benchmarking with Bencher and how that could have helped prevent all of that anguish and pain before. And yeah, that's just awesome. So in review, detection is required for prevention. Production is too late. Development is local only. And continuous benchmarking can save us a lot of pain. So with that, thank you all so much. This has been Run Fast, Catch Performance Regressions in Python. That's the GitHub repository for Bencher if you want to check it out. And if you wouldn't mind, please give us a star. It really does help the project. And if that GitHub link is too long to type out, then you can just go to bencher.dev/repo and it'll redirect you right there. All right. Thank you all so much.